Okay, today we're dealing with light gauge steel framing. What you see in this picture is light gauge framing that is very much like what you see with a wood framed house. We basically, with light gauge steel framing, we're essentially using framing parts made of sheet metal that are bent into the shapes to be like you would do with wooden framing. So essentially it's a metal version of wood framing. We also use light gauge steel framing in commercial buildings like structural steel and precast and cast-in-place concrete. There's openings that end up getting framed up with steel framing like this. And we have in commercial buildings wall framing. We can't use wood in most commercial buildings because of the fire hazard, and so we use metal parts very often, even for interior framed walls, partition walls and stuff. But here we're looking at the framing of the outer skin of the building with light gauge steel framing. The framing on the outside of the building will be heavier gauged metal because it has to deal with wind loads of the wind blowing against the side of the building compared to the walls that are interior inside the building. Okay, so the concept of light gauge steel construction. Light gauge steel framing members, these components are basically cold rolled steel as opposed to the hot rolled steel we were talking about in chapter 11, where we were dealing with I-beams and such that are semi-molten material rolled into those shapes. This is sheet metal. This is just plain and simply cold metal that's bent into these shapes. So like I said, members are essentially non-combustible equivalents, there's the word I was looking for, of wood light frame construction. Okay, so wood compared to steel, or maybe steel compared to wood, the steel is lighter than wood. You could have a stack of 10 metal studs over your shoulder a lot more easily than you could have 10 2x4 studs over your shoulder. A lot less weight. It's non-combustible. The metal doesn't burn. Now, the metal structurally has to be protected from heating up if it's structural. So we have to encase metal studs in fireproof material. Even though it doesn't burn, it can melt. If it's got any structural element involved, it's a problem. It's generally straighter and more uniform than wood. But it's more fragile. If you drive over a stack of 2x4s with your truck, you're probably not damaging much. But you drive over a stack of metal studs, you're probably ruining them by just bending them out to the point where they're not useful. Okay, so the first one we're looking at is the stud. So you see how a metal stud is basically a kind of a C shape. It's like a U, but the returns bend in. So that's an important component, and that gives it some rigid structure because of its shape. The code system down here, you see this example of 600 S162-54, right here where my cursor is running. So the 600 is talking about 6 inches for the width of it. You know, a 2x4 stud might be 3.5 inches. Well, you could have 350 before the S. The S means stud, even if it's a very wide stud or not. They don't care. They're just S for stud. So it'd be, and I'll show you in a moment why this matters here. The 162 is 1.62 inches for thickness. So that's, talking about this dimension going up. And then we've got a dash and 5/4. The 5/4 is telling you how thick the metal is because there are different thicknesses of studs. So for exterior grade studs, for the exterior walls, if you were wrapping the outside walls of a building with it, and then you would want heavier gauge material because it's got to be able to not bend in when the wind blows. Whereas when you're talking about partition walls that aren't carrying any load, wind loads or otherwise, then they could be a thinner gauge material, and it's easier to work with the thinner gauge material. It's easier to cut, easier to bend, and all of that. Okay, on the next page, we're looking at tracks. So you see how the track is a U shape, and they dimension it so that you can take this stud right here and slide one end down inside of the track. The idea is that you use track for the bottom and the top plates of the wall, and you fit the studs inside that space. And they fit by friction pretty much, but you don't just do friction. You typically put a screw at each side right through the track and into the stud. So this one, track, it's got the letter T in this description. It's 600 T 125-33. So in this particular case, it's 6 inches wide again, but of course it's actually 6 inches wide inside to inside. The T stands for track as opposed to stud with the S. And then you got 125, it's 1.25 inches high, and it's 33 mils thickness, 33 1,000th of an inch. What that means. So there's code systems involved here. Channels, well, they're often used to fill in spaces and make channels for various reasons, and so they'll have the abbreviation U, but they use the same kind of idea. It's 0.75, it means it might be 3/4 inches wide. 50 might be 1/2 inch thickness, and then the -54 is the 54 mils. And then there's furring. So the furring is probably more useful than track. So going back to the furring, we have strapping material that could be strapped on a wall. That's very often where it's used for. Bridging, backing, furring, I'm calling it strapping, but all those things are kind of a type of strapping where if you were using wood, you might shoot some 1x4 material against a concrete wall with either concrete screws or with, I don't know, maybe concrete nails, but more often a powder-actuated fastening tool, gunpowder-powered fastener that you shoot into it. And then you could then put drywall against that. So you get something to fasten the drywall to. And so the hat channels can be used for that kind of purpose too. And then there's L header pieces. If you're building a beam across the door in sheet metal, that means constructing it out of a whole bunch of metal parts. So there's more labor right there. Just having to take a bunch of parts to go and make a header out of a bunch of collection of parts that you screw together. And by its shape, kind of making a box of sorts. And so then they can have L for the L header, L kind of the angle iron kind of shape, although it's not angle iron per se, it's sheet metal that's bent in an L shape. And there's other framing parts that could be used for other purposes. And one of the things with framing with metal like this, sheet metal parts like this, is that there's a lot of brackets needed and there's a lot of bracing, extra bracing. So here's an example of a stud, this dimpled thing here, that is basically been chewed up by a machine that's basically making a whole bunch of dimples all over it. And out of that, it actually surprisingly ends up adding strength to the shape because you've got all these little three-dimensional dimples in here, and it tends to make it stronger. It's kind of a funny little thing, but anyways, that's an idea. And then around doorways and windows, we will sometimes use heavier gauge metal, maybe even more rigid with some additional shape in here for framing around a window or a door, because windows and doors need a more rigid opening, especially doors. Another trick, remember the bottom track that we were looking at before, sometimes they'll use that only for bottom track, and for the top track, they might use a slotted track. So they call that a slip track, as you see at the top. The top track has extra deep legs. Yeah, okay, going down more, maybe 2 inches down or something, or maybe more, with slots in it. So you see these slots that are in the track, where the idea is that you can screw through a slot in the track into the stud, and you can maybe not snug it so tight on the screw, so it's held in place, but it allows for some movement. If you get the upper floor with a bunch of extra weight, it could deflect and start dipping down. And if you've got a rigid partition wall that's not supposed to take any load, it's not strong enough for that, it could literally bulge or deflect, and you can literally have drywall. You could have a drywall buckle, you can have studs buckle, And so in order to take that kind of additional movement on a non-load bearing stud wall, it's not uncommon to have slip track in the top so that as it deflects, the screws just slide along, in that oval track. Here's some heavier jam material for door jams. Again, you see how there's a slot cut in here? That's meant for the striker, the latch, so it can hook in. Not that they're using that hole except for a cavity for your striker plate, so you've got room for the striker piece to go into some cavity. So when we're talking about the metal thickness, it matters, and so one way we measure thickness of metal is by gauge, just like we do with electrical wiring, where the bigger the number, the smaller the wire. So a 12 gauge wire or a 12 gauge metal here in this first column, that's thicker metal than 14 gauge, which is thicker than 16 gauge, which is thicker than 18 gauge. So this, as you're going down this run from 12 to 25 gauge, you see an assortment of thicknesses of metal. Now, in actual measure of how many inches thick, well, we're not talking about not even 1 inch thick, not even close. The thickest stuff here is like 97 1,000ths of an inch, or 2.46 millimeters. So when you're looking at gauge of material, yeah, we often talk about the gauge in numbers because it's just easier to say, but more precise and more specific, you might be, as you were seeing in the naming, we had an example where we had 54 thousandths of an inch. And so as you're going down this line, you're getting to thinner and thinner metals. Okay, but you'll notice that one column here was load-bearing framing. They're generally going to be heavier steel used in load-bearing framing. Even if it's wind loads on the outside of a building is all you're taking, that's a significant wind load. You're going to be somewhere in this neighborhood of 14 or 16 gauge probably in most cases. Non-load bearing, it could be in that range, but it could be less. And so I've seen plenty of metal studs that are non-load bearing available in places like Home Depot and Lowe's, but not the load bearing kind, because that's probably more of a special order thing that you're going to order from a different kind of supplier like Acoustical or something. Some of the tools we use for light gauge steel framing, yeah, we use tin snips all the time. Pretty much every worker that's working with studs, metal studs, light gauge steel framing is going to have at least one pair of tin snips in their pocket or their pouch. There are nibblers that you see up at the top here that can be used. In the plants, these are both important tools because you can buy metal cutting blades to put in circular saws, but in the plant, you're not going to be using a circular saw or a angle grinder as much because of the sparking hazards. You need a special hot work permit to do that kind of work. Cutting torch, everything else. So we try to use intrinsically safer tools that don't create as much sparking. And so you could be dealing with a nibbler. Electrically powered is what this one is, but it could be air-powered nibbler too, which would be another level of safety as far as sparking hazards. We use a lot of screws, fasteners, and the screws typically have a self-tapping tip on them. So the self-tapping tip tends to look like you see in this drawing here on the tip, where there's a section that's just a little funny like this, almost looks like a drill bit. And it allows you to drill a hole and the screw all in one fell swoop. And yeah, the heads could be Phillips, they could be a square drive, what we call up in Canada Robertson screwdrivers and Robertson screw heads. And then there could be some Torx in there, but mostly I think you see a lot of hex heads, little 5/16 of an inch to 1/4 inch hex heads as screws used, and you might see square drive and some Phillips too. These particular heads are what we call a wafer head. They're a thinner head. Right here at the top one here, and that really does help if you're putting something like drywall on the surface to not have a bigger, chunkier screw head sticking out. This other tool you see down here is a crimping tool. So sometimes when you're dealing with thicker material, they may have a crimping tool that they use to hold it in place temporarily until it gets tacked. With thicker, load-bearing materials, we can more easily tack it with a kind of a weld, a puddle weld or a tack weld of some kind. And so we'll sometimes use wire-fed welders to go and do a weld connection instead of screws. And they'll crimp it to hold it temporarily until it's gotten welded. But plenty of walls have been put up with nothing but self-tapping screws. So here's an example of welding where they're filling in a slot, and plug welds or slot welds or flare welds and stuff like that. So here we are looking at another impressive steel-framed, light-gauge steel-framed house. Not a bad idea in Louisiana, especially if you're in a flood-prone zone. So framing methods parallel what we do with wood-light framing. The only thing is that with wood-light framing, we can use a nail gun and put a lot of nails in the wood pretty fast and easily. And not just that, but in ways where it's useful. In metal framing, we end up having to put a bunch of screws in and a lot of brackets. We use web stiffeners or reinforcing or inserted. So right here, for instance, right there, we've got a web stiffener at the end of this joist to get a better connection with the outer joist, the rim joist, or whatever you want to call it. So the web stiffener is a really common extra part that's used. It fits inside and screws to both pieces, but it means that there can end up being a half a dozen screws involved in making a connection that you might be able to do more easily with nail guns with wood, but you're not going to do that with this. And so you could be required to do more bracing more often also. Construction panels are often fastened with mastic adhesive and screws. So we use a lot of screws even to put the plywood subfloor down to get a good connection there. We glue it down with a mastic bead of glue and then put the screws in place. Heavier beam equivalents such as ridge beams could be a combination of pieces. You see what's going on here in this left-hand picture on the ridge for the main ridge board. To make that, they had to take two pieces and they literally nest one inside the other to make the box. And that gave you a solid place to fasten the rafter on with a bracket on every side. So you can see that every connection like this is a 90-degree connection requires some kind of an angled bracket. So you end up being a lot more labor involved. A lot, maybe 20-25% more labor. So that has to be considered when you're thinking about the cost. There's some joist hangers being fastened here to hold on to this joist. We've got steel gusset plate there. There's a window header being built out of all these pieces of metal to make that box. Bracing. These members are more slender, so they require bracing more often than you would with wood. So slender members require more bracing, regularly spaced intervals. So these are not going to be as rigid as their wooden counterparts would be. And so they can vibrate. They're going to have to be, they're not going to twist and warp either, but they're going to be, to have a rigid enough wall, you may have to do additional bracing. So they've got some bracing going on right here, and up here maybe less than 4 feet away, really, I think. So you see what it roughly would be, a clip angle that's screwed into the stud and then screwed into the brace in order to make everything rigid. You cannot put electrical wiring in metal stud wall without having a little rubber grommet, because you don't want that insulated wire to be rubbing on a sharp cutout piece, a knockout area that's in through the body of the stud, where that insulation could over time work through and literally start charging and tripping breakers and maybe starting electrical fires and all kinds of stuff. So yeah, down here on the left, we're looking at a partition wall that is not load-bearing. That would be a good place to use that slip track. Whereas over on the right-hand side, we're talking about exterior grade studs and framing, metal studs, and that would be load-bearing here, because even though it's not holding up the building, it is load bearing if it's on the outside of the building, because on a big wall like that, the wind can really be a surprisingly huge force. And so the studs have to be strong enough to be able to withstand the wind forces. So there's a good summary page on a lot of these advantages and disadvantages. Okay, the advantages of light gauge steel framing compared to wood would be, like wood, light framing is versatile, flexible, simple to construct. The next point, non-combustible and immune to insect attack. Next point, dimensionally stable. It's not going to twist and warp. It's not going to change with temperature or moisture. With consistent material properties. It's lighter weight than wood. Okay, now the disadvantages. Members require more frequent bracing. This stuff readily conducts heat through a wall system, so that's a problem. It's a thermal bridge to send temperature through, so it really needs to be isolated with a thermal break to keep the temperature from migrating through. And the last point is it is susceptible to corrosion. Yes, it's kind of got an electroplated galvanizing coating, which gives it some protection, but that is a coating. And so if it's submerged for a while, or if you get a funny little reaction happening, you can end up with corrosion that's surprisingly bad. Here's a couple of snapshots here from the library building, and so they're looking at the same pile of studs here, and these are structural. Here's a picture at the top of the label, so it's structural studs. In here, they do not say on this particular label what the thickness of what this material is, but these were long studs, and you'll see where they were installed. These were like 10, 12, 14, 16 feet long, some of these studs. And you see they're roughly somewhere in the 8-inch. Yeah, these are 8-inch studs pretty much. Here's some interior non-load bearing studs. And I guess these are like, looks like they're 6.5 inch, roughly, maybe something like that. So here's a stack of where are these? Non-structural. So these are non-load bearing. I'm trying to see in the labeling here, does it say anything about the thickness? Well, it kind of does. It said 250, so 2.5 inches, PDS, yeah, 125, so 1.25 inches, and 19/1000ths of an inch. So it's pretty thin stuff. But here's why they had to be very long. If you're going to stand them up like a wall on the outside of this thing, it's got to be strong enough to withstand the kinds of forces you're talking about. Here's some detail around the column. You see this? Let me go back here. This is a steel column on the corner, and it's been fireproofed already, so it's already fuzzy or furry with that spray applied coating. And then there's some more coating here and here in frame in structural steel that's been protected from fire. So you see that furry post there. Well, they've wrapped around this post with studs, the boxing around it, so that you're not getting a direct pathway there. But then we put this sheathing on top. Now, the sheathing we put on top in commercial will often be an exterior grade of drywall and an exterior grade of gypsum board. So you're seeing these sheets of drywall or sheetrock, basically glorified sheetrock that's meant for weather a little bit. It's not like it's super waterproof or anything, but it is more durable than regular sheetrock. And when you're looking up close, you will see in close writing, you can kind of sort of see extended exposure sheathing. So it's meant to take higher humidity, at least. And here we are. We're looking at the actual sheathing on one wall, and we're seeing that where it's not over on the other wall. Now, so it's been installed here. Let me back up for one more moment. One of these pictures, well, maybe this is the best picture. You're only seeing a little bit in this picture of this mastic that they're coating here. Basically, before they can cover all this up with anything else, including even a house wrap material, some kind of a Tyvek kind of material they could put on. Before they do that, they will take and seal all those joints and that helps to keep the drafts from blowing through that wall. And so right now, there's just starting with the easiest stuff down low. I think that's all we have that I really need to cover in Chapter 12 on light gauge steel framing.